This video is on lesson 4-6, isosceles and equilateral triangles. New vocabulary will be the legs of an isosceles triangle, the vertex angle, and the base angles. The isosceles triangle theorem states that if two sides of a triangle are congruent, then the angles opposite those sides are congruent. So if I have segment AC and segment BC, segment angle B is opposite segment AC, and angle A is opposite segment BC. Those segments are also congruent. Remember, the converse states the opposite. So the converse of the isosceles triangle theorem states that if angles 1 and 2 are congruent, then the sides opposite them are congruent. So here is angle 2. The side opposite is DE, and the side opposite of angle 1 is FE, and therefore those sides are congruent. Remember from our previous lesson that this is an isosceles triangle. Remember that the angle formed by the congruent sides is called the vertex angle. Additionally, the side opposite the vertex angle is called the base. The two congruent sides are called the legs, and the two angles formed by the base and one of the congruent sides are called the base angles. The base angles are located here and here. Name two unmarked congruent angles. So if I look at my picture, I see that angle BCD is congruent to angle D, which means that this side and this side are congruent. I also see that CB is congruent to AB, which means that the base angles are also congruent because they are opposite. Therefore, angle BCA is congruent to angle A. I can also find two unmarked congruent segments, which I already did previously. This angle is congruent to this angle, which makes this segment congruent. Therefore, BC is congruent to BD. Now it is your turn. Remember that these angles are congruent because they are opposite congruent sides. Here's another example. Segment PM is congruent to segment PK because they are opposite the congruent angles. Here is the equilateral triangle corollaries. Remember, corollaries do not require the same amount of proof as a theorem. A triangle is equilateral if and only if it is equiangular. So if all three angles are congruent, that tells us that all three sides are also congruent. Additionally, I know that each angle of an equilateral triangle measures 60 degrees. So if I know that the sides are congruent, I know that the angles are congruent, which means that they must be 60 degrees because 180 divided by 3 is 60. These corollaries are actually converses of each other. If we want to find the measure of angle R, I will have to decide what kind of a triangle this is. Since PQ is 5 centimeters and QR is 5 centimeters, that lets me know that this is at least an isosceles triangle. How do I find angle P and angle R? Well, I know that if these sides are congruent, these angles are congruent. Therefore, I would take 180 and subtract 60, and between angle P and angle R, I have 120 degrees. Because P and R are congruent, I can take 120 degrees and divide it by 2, and each angle is going to be 60. Therefore, the measure of angle R is 60 degrees. Since there are two congruent sides, I know that the base angles that are opposite those sides will be congruent. I already found out in the previous slide, since this is 60 degrees, that each of these angles is 60 degrees, which lets me use my corollary that states that if the angles of a triangle are all 60 degrees, then it is equilateral, which means that PR is going to be 5 centimeters. Here is your turn. Please find the measure of angle T. Angle T is 60 degrees because since this is isosceles, the angles that are opposite the congruent sides are congruent. If angle S is 60 degrees, then angle T is 60 degrees. Here's another example. .5 is my correct answer due to the fact that if angle S is 60, we know that angle T is 60, which means that angle R will have to be 60 degrees, which means that even though it looks like it would just be an isosceles triangle, we can see that it is actually an equiangular triangle, which means that it is equilateral. If all the angles are the same, then all the sides are the same, and therefore B is my correct answer. Here's another example. B is my correct answer. Since all the segments are the same, I know this is an equilateral triangle, which means I know that all the angles are congruent. Therefore, I know that 3x is equal to 60 degrees, which means that x is equal to 20, and 8 is equal to 2y minus 6. And when I solve that, I get y is equal to 7. Here is another example. S and T are my correct answers because RS is part of the big triangle and RT is part of the big triangle, and therefore I need the angles that are part of the big triangle. The correct answer is C. The reason the correct answer is C is because angle RUV, which is here, is going to be 65. And since this has the same arc, this is 65. 65 plus 65 is 130. And 180 minus 130 is 50. Please remember that when a triangle is equilateral, you don't have to use all three sides in the same equation. You would just pick 2 to find your value of x. 10 is my answer because if I set any 2 of these equal to each other and solve mathematically, I get 10 as my answer. That concludes the notes for 4-6 isosceles and equilateral triangles. Please remember to bring any questions you may have to class.